Okay, next we go to the next learning objective in 11.2, which is state and use Decay's law. So we only have to state and use sahaja. So what is Decay law? Okay, so this is the most important thing juga lah. So we have to know what is law of radioactive decay. So law of radioactive decay states that for a radioactive source, the decay rate, which is decay rate ialah negative dN over dt, is directly proportional to the number of radioactive nuclei present in the source. Okay, so or in another words, negative dN over dt, it is directly proportional with number of source. So this is the relationship. Okay, so relationship ni ialah dN over dt is directly proportional dengan number of nuclei present in the source, directly proportional dengan n. Okay, so secara mathematically ataupun dia punya equation, so disebabkan ini hanyalah relationship, kita perlu convert into equation. So to put equation, we have to put one constant, so we have to put delta lambda here, where lambda ialah decay constant and unit for lambda is per second. So dN over dt is equals to negative lambda n. Okay, so from here the relationship kita kena ubah kepada bentuk equation, baru ada sama dengan. Okay, so as we know here, lambda is the decay constant and n is the number of remaining nuclei in the source. Maksudnya berapakah number of nuclei yang ada dalam source kita. Okay, and the negative sign, it's most important part, means the number of nuclei present decrease with time. Sebab tu ada negatif kat sini, maksudnya by the time goes, number of nuclei ini juga semakin berkurang. Okay, next we need to know, so this one is important. So this is the definition, radioactive decay. Okay, so define and determine activity and decay constant. So tadi kita dah belajar dN over dt directly proportional with n ialah decay, law of radioactive decay. Now we go to activity. Activity simbolnya ialah A. So activity of a radioactive sample is defined as the rate of decay of the sample. So secara matematiknya, activity is equals to dN over dt, and we also known here dN over dt is equals to negative lambda n. So activity ialah rate of decay of the sample. Okay, so the unit for activity biasanya kita guna becquerel. Okay, dan becquerel juga dia bersamaan, kita juga boleh guna Curie, 3.7 eksponen negatif 10 decay per second. Okay, so semua unit ini kita boleh guna, which is becquerel boleh, Curie boleh, number of decay per second also boleh. But we have to know the sign conversion. 1 becquerel bersamaan 1 decay per second, 1 Curie bersamaan dengan 3.7 eksponen kuasa 10 decay per second. So this one, pentinglah unit conversion ni. Right, so you boleh guna becquerel, boleh guna Curie, boleh guna decay per second. Okay, right, so we have known activity. Activity ialah dN over dt. Dan kita nak tahu juga what is decay constant. Decay constant simbolnya ialah lambda. So decay constant is defined as the probability that a radioactive nucleus will decay in 1 second. Dalam masa 1 saat, berapa banyak kita punya nukleus boleh decay. So that's why kita panggil sebagai decay constant. dN over dt equals to negative lambda n. So negatif lambda, kita susunkan balik this equation, akan dapat lambda equals to negative dN over dt divided by n. Okay, and the unit for lambda is per second. Okay, so kita dah tahu the first one, tadi kita dah tahu decay law. So this is the decay law, and we have known activity. Activity is equals to rate of change of the sample, rate of decay of the sample. Dan kita belajar decay constant. Decay constant ialah probability that radioactive nucleus will decay in 1 second. Okay, so pusing-pusing balik equation yang sama juga kita gunakan. Okay, alright. Okay, so the unit for activity kita tahu becquerel, and the unit for decay constant ialah per second. Okay, then we go to the fourth learning objective, fourth and fifth, which use n and not e negative lambda t, a and not e negative lambda t, and define and use half-life. Okay, so kita tahu decay law kata rate of decay equals to negative lambda n. From this equation, kita boleh derive dua lagi equation, which is the first one, kita akan dapat a equals to n naught negative lambda t, and the next one kita boleh dapat n equals to n naught e negative lambda d. Okay, so a ialah activity at time t dan a naught ialah activity at time equals to 0 ataupun kita panggil sebagai initial activity. Okay, and n juga equation yang sama, cuma kita ubah dia punya simbol. Kalau A activity, kalau N number of radioactive nuclei at a time, yang ini number of radioactive nuclei initially. Sebab initial at time equals to 0. So these two equation is given and you have to know how to use the equation. Okay, and next you have to know what is decay curve. So decay curve ialah basically ialah bagaimana sesuatu nuklei itu boleh decay, okay, terurai. So kita ada number of nuclei against dengan time. As we know that dia decay, dia terurai. So pada awalnya kita punya number of nucleus ataupun number of nuclei dekat dalam nukleus kita ialah n0, penuh. Okay, at the time goes, dia akan berkurang menjadi separuh. Bila number of nuclei kita menjadi separuh, dekat sini kita punya time ialah half-life. Okay, half-life itu bukan masa yang separuh, tetapi half-life ini ialah bila mana kita punya number of nuclei ini menjadi separuh. Okay, bukan masa yang ni, bukan masa yang separuh. Okay, so half-life, then we goes to the half-life, dia ialah the time taken, masa yang diambil for sample of radioactive nuclei to decay to half of its initial number of atom. Macam saya kata tadi, dia bukan masa yang separuh, bukan time ini yang separuh dekat sini, tetapi dia ialah masa yang diperlukan untuk this thing mentukar menjadi separuh. So bila n kita dah jadi per 2, n naught dah jadi per 2, initial ialah n naught. Bila n naught tu dah jadi half, so at this one, time kita ialah half-life. Okay, so it also can be defined as the time taken for the activity of a sample of the nuclide to become half of its initial activity. So the equation for half-life ialah T half equals to ln 2 over lambda. And unit for half-life, sebab dia time kan, boleh jadi second, minute, hour, day and years. So unitnya depends on the unit of decay constant. So the unit ini depends on unit lambda. Okay, alright, so that's for the second part of 11.2, and in the next video I will show you how we do the example 9 and example 10. Right, so that's it. Thank you.